Let's start off things by going through our assignment. So there's just a few questions, um, and they're pretty easy. The stuff we're doing in class is actually way harder than I'll test you on, but it's kind of fun to do the trickier ones. So this has 2 carbons, so this is eth, and it's all single bonds between the carbons, so it's ethane. We have 3 carbons, so it's prop, and we got a double bond. So it's ane. You don't actually need to, you could answer this prop 1 ane as well, but it's not necessary, but I wouldn't mark it wrong. And then this has got 1 carbon, so this is methane. Okay, and then draw the structural diagram. Given that, you can draw it however you want. So propane is our parent, so we have 3 carbons for propane, and then 2,2-dimethyl, so it's got a methyl on there, and then you just have to put your hydrogens on to make sure every carbon has 4 sticks. So those are all hydrogens. I'm not going to fill those on, but that's what it would look like. And then 2-methyl prop 1-ene. Okay, I'm going to draw that up here. So prop again is 3. It's got a double bond on 1. And then a methyl on 2. So this should have 2 hydrogens, that's 4 sticks. This carbon in the center already has 4 sticks. This one needs 4 sticks. And that one needs 4 sticks. Like that. Okay. To not draw the hydrogens on, you could draw it as a line diagram. So the double bond's there, and then that one's on 2, and that's a little bit easier. Draw and name 3 common organic compounds that we use frequently. So methane is one. Methane is the main thing in natural gas, so the gas that goes to your furnace. Propane we use in barbecues. Butane we use in lighters. And then octane we use in gas. That's the main source in gasoline. So those would all be good answers for that. Okay, functional groups. So we have to identify and name carbon compounds using IUPAC, which is exactly what we're learning. IUPAC, if you ever see that, it's just like how we do it. For single occurrence of a functional group, including simple halogenated hydrocarbons, describe the common uses of hydrocarbons, including simple halogenated hydrocarbons, alcohols, carboxylic acids, and esters. Okay, so what a functional group is a characteristic arrangement of atoms or bonds within the molecule that determines the most important chemical and physical properties of a class of compounds. Okay, so what that means is that these are our functional groups here, not this one. You don't need to know about that. But these are our functional groups. So if I have an OH on the end, that makes it an alcohol, and it'll behave just like other alcohols, right? So if we look at this as an example, this is ethanol. So this kind of looks like ethane, right? But because it's ethane with an OH on the end, it just means that it behaves like an alcohol, and it'll behave more like an alcohol more than it'll behave like ethane. It'll have different boiling points. It'll have characteristics like that. You'll notice these R's here. These R's just refer to any length of carbon groups, right? So I could have like this bonded to an OH, and this would be R, right? For this one here, I could have this bonded to OH like that. So I'm just drawing this one right here, and this represents R. So it's just whatever length of carbon chain. It could be 2, 3, 4, 5, anything. So in your data book, it gives you a drawing, it gives you the name, it gives you an example of the drawing, and it gives you an example of the name. So this is really helpful in the test, and you can use it. It's on page 9 of your data booklet. Okay, so we're going to start off with alcohols. So alcohols are organic compounds that have an OH or a hydroxyl. That's what the OH is called, a hydroxyl functional group bonded to the carbon atom. The general formula for alcohols is ROH, where that R is any 2 carbons, 3 carbons, 4 carbons, however many carbons we want. So it's really important that you don't mix it up with a hydroxide ion, which we did earlier in this unit. And the hydroxide ion is bonded to a cation. It's bonded to a metal. So NaOH, that is not an alcohol because that's a metal, and a non-metal, that's a base. Right, so the hydroxide ion has one electron, becomes negatively charged. The hydroxyl group is covalently bonded, so they share, you learned that in grade 10, to another non-metal, and is found in a molecular compound. Okay, so to sum that up here, hydroxyl is an alcohol. Hydroxide is bases, and they both look like OHs, right? They both have OHs on the end, but they're different. So hydroxyl, which is an alcohol, will always be attached to carbon atoms. Hydroxide attaches to cations, and cations are things like sodium, calcium, right, magnesium. So hydroxyl does not affect pH, and hydroxide make things basic. So an example of a hydroxyl group would be like this. If I had, and these are all hydrogens, if I had something like this, this would be a hydroxyl because it's all bounded to carbon. Hydroxide would be something like magnesium hydroxide, right? It looks very different. There's no carbons. So this is a base. This is an alcohol. Okay, so identify which of the following compounds below are alcohols. So you can give this a go. So is that an alcohol or is that a base? It's an alcohol, right? Because it's bonded to carbon. Is that an alcohol or a base? It's an alcohol, right? Because it's bonded to carbon. Is that an alcohol or a base? It's a base because it's bonded to a metal. Is that an alcohol or a base? It's an alcohol because it's bonded to carbon atoms, right? So if you see carbon, it's alcohol. If you don't see carbon, it's going to be a base. So alcohol naming rules are, they're pretty similar to alkenes. So number the longest carbon chain that contains the OH group, then number the carbons to give it the lowest, the carbon bonded to the OH group, the lowest number possible. So just the same as alkenes. Indicate the position of the OH group by ending the parent name by dropping the E and writing a number on which the carbon to OH occurs if it was found, and then add an all. I'll explain that. And then indicate the number, indicate by number the position of any groups attached. So it's almost identical to alkenes, but instead of ending in "ene," they end in "all." Okay, so this is what that one was saying. So propan 2-all. So we take propane, we drop the E, so it becomes propan. The 2 is where that double bond occurs, not double bond, where the alcohol occurs, and this tells us that it's an alcohol. So what we do is we draw propane like that. The alcohol, the OH, occurs on the second one, and the all tells us that's an alcohol, and then these would just be hydrogens. So this is what propan 2-all would look like. Okay, so let's do an example. So we find our longest parent chain like that. So we have 1, 2, 3, 4, 5, 6. So this would normally be hexane, but I don't put the E because I drop it. So this is hexane. We can start counting from here as 1 or here as 1. Obviously, we're going to start here because this is closest to our alcohol. So that alcohol is found on the first carbon, and we call it an all. Right? And then here we have a methyl group off to the side. So this is carbon 1, carbon 2, carbon 3. So my methyl group is found on the third carbon. So it's going to be 3-methyl hexane 1-all. Okay. So do this in a board question. Just to let you know before you start is that these are carbons right here, but there's no carbon on the end. This is a stick that's attached to the OH. So there's only 4 carbons. Okay, so give it a go. So the name would be butane, but we drop that E, so it's butan, and then the OH is found on the first carbon, so it's butan 1-all would be the name. So draw butan 2-all. I'm going to draw it as a stick. 1, 2, 3, 4. which is attached to the second one. So uses of alcohol during COVID right now. Isopropyl alcohol, very important for washing your hands. So this is a common name. We use IUPAC. This is a common name. So isopropyl alcohol is just like this. It's propanol. That's where the propyl, and then the iso means that the OH is in the middle there. So it'd be two. So it'd be propan-2-ol would be the isopropyl alcohol in IUPAC. So that's an example of an alcohol. And obviously the alcohol that we drink is alcohol. So yeah, it's ethanol. Ethanol is the alcohol that we drink. Okay, so let's do another example. Naming rules. So name these just like branched alkanes. At times you might find a halogen attached as a branch. So naming these branches is simple. You just drop the ene and add the O. So halogens are group 17 of your data book. Let me open up a data book here. So if we open up to the middle of our data book, we have our periodic table. So all the halogens are here. So we have fluorine, chlorine, bromine, iodine, acetine. So they all end in ene. So we drop that ene and change it to O. So what that means is fluorine becomes fluoro. Chlorine becomes chloro. Bromine becomes bromo. And iodine becomes iodo. And if you were a halogen, what would be your name? Because my name would be Mr. Lato. Yeah. Anyways. So an example, so halogenated hydrocarbons, they're just branches. So this is propane, right? 3 carbons. And then we have a bromine on the second one. So we would say it's 2-bromo propane. Okay, so examples of alkyl halides that we might see. So CFCs are one that we're going to talk about quite a bit. This is chloroform here. We all know chloroform as you inhale it and it can knock you out. And it was used way back in the day by anesthesiologists, but they found it was a carcinogen, so they don't use it so much anymore. So it's inhaled anesthetic. Same with this one. Halothane is an inhaled anesthetic. Same with chloroform. Okay, so try this as a board question. Pause the video and see if you can do it. So we have 4 carbons in the middle. So it's butane. And then we have fluorine here. And it found on the first carbon. So 1, fluorine's hard to spell, F-L-U-O-R-I, fluoro, like that, F-L-U-O-R-O. Sorry, 1-fluorobutane is the name of it. Okay, give that one a go. So we have 3 carbons, so it's propane. So it's 2-fluoropropane. Okay, so our next functional group is carboxylic acids. So there are 2 classifications of acids. There's inorganic, which is like, we give examples here, which is HCl, HF, H2SO4. So you can see there's no carbon, so it's inorganic. And then the other one are organic acids, and that's when you have carbons attached to it. So all organic acids have this COOH carboxyl functional group, which we talked about before. The COOH shows that it's an acid. Vinegar is an example of one of those. So the carboxyl group may be written COOH, but it actually looks like this. And remember that this is in your data book. It's got C double bonded to O, and then OH like that. So naming carboxyl groups, similar to alcohols, we drop the E, but we add oic acid. And carbon 1 is always the carbon attached to the carboxyl functional group. So we don't have to name any numbers with these, which is nice. So if we did an example here, so we can draw it like this, but it's sometimes nicer to draw it like this. So we have the double bond O and then OH. So this is what it looks like. And then there's an H on the other side of the carbon. So we have 1 carbon, which makes it methane, but we drop the E and it becomes methanoic acid. So we always add oic acid. 2 words. This is the first thing that's had a space in it so far. Okay, and then this one here, these are both the same. Sometimes if you have a bunch of CH2s in a row, they draw it like that. So it's not a branch, it's just saying that there's a bunch of them. So we have CH3, CH2, CH2, C double bond O, OH like that. So we have 4 carbons, which makes it butane. But we drop the E and change it to butanoic acid. Butanoic acid, a little fact, smells like, if you've ever smelled like scraped at the bottom of your toenails and then you get that cheesy smell, that's what butanoic acid smells like. Very nice. Okay, so do this one as a board question. Oh, this is butanoic acid again. We have 4. So this is butanoic acid. Oops! I'm going to take a carbon off that last example. Anyways, so examples of organic acids are vinegar, right, which is CH3COOH. Ethanoic acid, we have 2 carbons. There's a carbon, so 2 carbons, so it's ethanoic acid. And then this is citric acid, which is in fruit and makes things sour. So citric acid is another example of an organic acid. And citric acid is super complicated, so you don't have to write that one out. Okay, and our last functional group are esters. So esters are formed through the reaction between an organic acid and an alcohol in a reaction called esterification. The products of an esterification are ester and water, and this is what it looks like. Okay, so this looks confusing. So what we do is we take a carboxylic acid and we take an alcohol. And then what we do is we take the OH off of the carboxylic acid and the H off the alcohol. And we have HOH, so that makes our water. You can see they're color coordinated. And then we just connect these guys there. So we can see in red we have RC and then double bond O. RC double bond O. And now there's a line connected to the blue O and the R, like that. So that's how we make an ester. Okay, so we'll go through how to name it, and then we'll do some examples, we'll do some board questions, and then on Friday, we are going to practice it a little bit. So I'm going to give you a sheet to practice it, because esters are the thing that students have the biggest trouble with. Okay, so to name an ester that's formed, we take the alcohol name and place it down first, giving it an alkyl name as derived from the alcohol used. In the example below, methanol becomes methyl. And then next we use the acid name as our parent name. We drop oic acid and insert O8 at the end. So ethanoic acid would become ethanoate. Okay, so we would end up getting methyl ethanoate, which sounds super confusing, but I'll walk you slower through an example. Okay, so this was our example. So the first part of the name comes from the alcohol. So the methanol becomes methyl. And then ethanoic acid, we drop the oic acid and change it to O8. So it becomes methyl ethanoate in water. Okay, so let's do an example. So we have methanoic acid and ethanol. So we're going to name the ester that's formed from that. We're going to draw that as well. Okay, so let's give that a go. So we have methanoic acid. So we should be able to draw that. So methanoic acid, meth just means 1. So we have C double bond OH, and we have our 1 carbon, but this carbon's only got 3 sticks attached to it, so we need that 4th stick, and we use a hydrogen. Okay, and then our alcohol is ethanol, so ethanol means we have 2. And then when doing esters, I like doing my alcohol as a HO instead of an O here on the other side, and you'll see why when I do it. And then these are all my hydrogens. Okay, so what I'm going to do is I'm going to take my OH from my acid and my H from my alcohol. I'm going to take those off, right? And that makes my water. And then I just connect these guys together, and that's what my ester looks like. Okay, so the first part of the name comes from the alcohol. So my alcohol was ethanol, so it becomes ethyl. And then the parent name comes from the acid, so it used to be methanoic acid, so now it's methanoate. So it's methanoate and water. Okay, let's do another example. So sometimes I might just give you the ester, and this is what the ester looks like, and you would have to name it. So it's a little bit trickier because we can't use the alcohol acid technique. So a little memory technique is name the oxygen with the single bond first and the oxygen with the double bond second. So one bond is first. So this oxygen is bonded single bond to this. So that's where the first part of the name comes from. So we have one carbon attached to the single bond oxygen. So that means that methyl is one is the first part. And then here we have our double bond oxygen over here. So this double bond oxygen is attached to 1, 2, 3 carbons. So 3 carbons is propane. Oops, propane. But it would be propan O8 because all esters end in O8. Okay, so board question. So pause the video, see if you can do this on your own, and then I will go through it right here. Okay, so give it a go. Okay, so we have ethanoic acid. So 2 carbons because it's eth, and then to make it an acid, we go double bond OH, and then we just need 4 sticks attached to all our carbons. Okay, and then our pentan 1-ol means that we have 1, 2, 3, 4, 5, so that's pentane, and then my alcohol's on 1, but I draw it as a HO instead of an O, and then these guys all need 4 sticks attached to them. That's what it looks like. Okay, so we take our OH off of here and our H off of here, and we just connect them, right? And that's where we get our water from. And then this is what our ester looks like. So this was our alcohol, and this is our single bond oxygen bonded to this. So we have 1, 2, 3, 4, 5. So the first part of our name would be pentyl. And then our double bond oxygen is attached to 2 of them. So we have pentyl, 2 carbons is ethane, but we always end it in O8. So it would be pentyl, ethanoate, and water would be our products. Oops. Okay, so if you want to name this one, so pause it and try it on your own. Single bond oxygen first. So it would be propyl. Then single bond, or two bonds to the oxygen, we just have 1 of them, so it'd be propylmethane O8. Propylmethanoate. Okay, so these are all the things that use esters. So rum flavor, apricot flavor, peach flavor, pineapple flavor, orange flavor, cherry flavor. So esters are flavors, except for fingernail polish, which is my least favorite flavor, but the rest are all flavors. Okay, that's all. I'll post an assignment, give it a go, and I will go through it tomorrow. Thanks.